Hey everybody, and welcome to another episode of JavaScript Jabber. I'm your host, Charles Max Wood. I'm not sure where the other panelists are, but we have a special guest with us, and that's Douglas Crockford. Doug, do you want to say hello?
Hello.
One of the things that I find that we talk a lot about at the different conferences and the different things that I'm working on is open source software. And a lot of people have a lot of ideas around open source software, but we don't often think about the people who are building it and trying to maintain it. I had a friend, John, who came to me. He's been a guest on JavaScript Jabber a couple of times. He came and he actually said, "Hey, Chuck, I wish there was a show about sustaining open source." That really hit me where I live. And I have a few other friends who are working on projects related to this. So we all got together and we put together a show called Sustain Our Software. You can find it at sustainoursoftwarepodcast.com. It's a place where several people who are passionate about open source come together and have conversations about how it can be sustained and how it can be maintained and what we can do to help these maintainers continue to deliver us value that we build our software on. Most of the software we're building is based on open source, and so it's important to us to have that maintained and have it taken care of. Come check it out. It's been really interesting to listen to the conversations that they're having from people who are working in it all the time and just hear what they have to say about it. Once again, that's at sustainoursoftwarepodcast.com. By way of introduction, there are a few things that I want to call out, and then you can tell me all the stuff that I missed. But when I was getting into JavaScript, and this was probably mid-2000s, I was a Ruby on Rails developer and realized that I was missing a lot of stuff on the front end. So I started getting into JavaScript, and my friend AJ told me, "You have to go watch everything by Douglas Crockford." And so, I went on and I spent hours on YouTube and watched all of the videos and went and found your book, JavaScript, The Good Parts. And I was pretty amazed by all the stuff that you were putting out there. And so I've been really excited to get you on the show. And then I'm also good friends with Mark Grabansky from Front End Masters. And so I was looking through the list of authors over there because he gets terrific people to come in and teach stuff. And I was like, man, we really need to get Doug on the show. And so, we reached out and you said yes, which made me super happy. You're kind of, I guess, to me at least, one of the sages on the mountain for JavaScript. And, you've written extensively about it. And what's interesting about what you've done, in my opinion, is that you've not only talked about the things you like about JavaScript, but you've also talked about the things you don't like about JavaScript. And it seems like a lot of people, they pick a technology and then they go and they extol all the virtues and they leave out all of the stuff that they just kind of ignore because it's inconvenient. And so your background there is really interesting. And you've been involved in JavaScript for a long time. So I know I've probably missed some critical things about you and what you've done and your involvement in JavaScript. Do you want to fill in any gaps there? And then we can talk about some of the things with JavaScript, the good parts, and what you're working on and all of that stuff.
I started working with JavaScript in 2000. And the first year working with it was terrible because I believed what everybody had said about the language, that this was a subset of Java, and that's how I tried to think about it. And it punished me for my lack of understanding about what was going on. So early 2001, I finally read the JavaScript or the ECMAScript standard and then had this epiphany. This is a Lambda language. Nobody ever told us that. And understanding that particular part of its nature completely transformed the way I understood that language. So I now recognize this language has really good parts in it, in addition to the bad parts that I'd already identified and bled over. So in 2001, I started a company for doing what we'd now call single-page applications. We were a little bit early. We had it working, and it was great. And it was trying to convince our customers that you could write really good applications in JavaScript, and nobody believed that. It's like, that's not possible. It's a crap language. Everybody knows it's a crap language. You can't possibly do anything good building with crap. So I decided I needed to start explaining to people how this language actually worked in order to get them to have confidence to use our stuff. So in 2001, I was going to write a book, but I didn't because at that point, the JavaScript market was so small and the web was dying at that time. So it's like, there's just not enough market for this book, so I didn't write it. A few years later, the Ajax revolution happened and it finally took off. And then I decided, okay, now it's time to write the book. So I did.
Nice. And that was JavaScript, the good parts?
Yeah. And as you said, the premise was that there are good parts and there are bad parts. And most books about a programming language are written by advocates. So they strongly believe in that language and in most cases don't see the problems. But in this case, the problems are so immense that I felt it would be irresponsible to not tell the complete story.
Yeah, that makes sense. It's interesting because when I started really learning JavaScript, the parts that tripped me up, people just told me, well, you just don't know the language well enough. And I think to some degree they were right. But in other instances, as I learned more about what I didn't understand about the language, some of those language features, they didn't make a whole lot of sense to me. It felt like there were other ways that they could have done things that would have been more intuitive or would have made the feature more powerful or things like that. So, I'm wondering then how many of the bad parts are things that, could have been better versus things that would have been just easier to understand.
Some of the bad parts were simply mistakes because language was designed and released in too little time. It wasn't adequately tested before it went into the world. A lot of the mistakes were copied intentionally from other languages. And in fact, you can look at the history of programming languages and you can see profound errors in modern languages that go all the way back to Fortran. Fortran got some things wrong, but people get emotionally invested in features of programming languages. We like to think that we're so objective and scientific and critical in our thinking about this stuff that we're totally logical because we're the ambassadors to the computer.
Right.
We're all Mr. Spock and we all are brilliant in the way we assess this stuff, and we're not. The way we feel about our language is totally emotional. The way we feel about syntax is not rational. It's all about fashion. It's liking things because we think they're attractive or familiar, and we aren't aware of when these features are actually working against us. Our emotional perspective blinds us to what's actually going on in our languages. So I've been attempting to be more rational about it. And one of the techniques I use for doing that is trying to apply principles of minimalism to the languages. Like, okay, I've got this set of features. If I make the feature set smaller, can I still accomplish what I want to do? And does that make it harder or easier? And surprisingly, most of the time, making the language smaller makes it easier. But we're so in love with the feature bloat that perspective seems alien and impossible. And in fact, I offend a lot of people by saying this particular feature, you really don't want to be using that, but they love that feature. And so I'm attacking them. And that's not what I'm doing. I'm not attacking anybody. I'm just trying to show how we can do a better job when we're programming.
Yeah, it's interesting that you bring that up. I mean, several of the languages that are popular out there, Ruby and Python, come to mind. JavaScript increasingly, they have a large, standard library, a lot of functionality that comes with the language. And so what you're advocating is paring that back and then bringing in the parts that you need?
Yeah, so the standard libraries, in some languages like Java, the standard libraries are incredibly huge, right? So that in itself is a problem. That a complete Java manual is how thick now? It's just ridiculous. Yep. JavaScript has a very small standard library, which is good in some ways and bad in others. But it also contains a lot of features which are distractions or attractive nuisances. If your intention is to use every feature of the language in every program that you write, then you want to use those things, but those things are going to cause you to get into trouble. And there is no need to get into that trouble.
Right.
We're not paid to use every feature of the language. We're paid to write programs that work well and are free of error. And that turns out to be easier to do if you're working with a much smaller set of features that are really well considered and well designed.
So how do you begin to identify then the parts of the language that are going to lead you into trouble versus parts of the language that you really ought to be aware of and be using for your benefit?
There are a couple of things you can do. One is you can look at what causes errors. Like, I did that again. If you keep doing that, then that should probably be a clue. Let me look at what's going on here. Why do I keep making this mistake over and over again? Sometimes it's more an exercise. For example, in 2007 and 2008, there were a number of experiments trying to figure out a safe subset of JavaScript that could be used for things like third-party advertising on web pages. So you could bring in an ad, And it could have some JavaScript, so it could do interesting things, but it couldn't do bad things. And there were projects at Microsoft and Facebook and Yahoo where I was and Google. And the biggest problem we all had was with this. I don't need to explain what this is, right?
Well, I don't know that you do. I mean, some of our newer JavaScript developers may not be familiar with how the VM determines what this is referencing, but yeah.
So one of the problems with the word this is just having it in the language makes the language harder to talk about.
Yes.
Because this is also a pronoun, and so which this, it's sort of like pair programming with Abbott and Costello.
Who's on first?
Yeah. It's very, very much like that.
Yeah.
So the security problem with this is that at that time in ES3, if you call a function as a method, then this will be bound to the object of interest and everything works fine. That's object-oriented programming. But if you take that same function and call it as a function, this will be bound to the global object, which voids all hope for security.
Right.
And how do you deal with that? So the approach that most of those projects took was to have a code generator, or a transformer. Basically a transpiler. So you would feed a JavaScript program into it, and it would output a new JavaScript program that contained lots of indirection and runtime checking to be sure that this never gets out of control. So the approach that I took was, well, let's just get rid of this. We'll say if a program contains this, we'll reject it, and we won't let it run on our network. And because JavaScript has functions and lambdas, it's already a complete functional programming language. So anything that needs to be done can be written in that subset. That was my hypothesis.
Right.
So, Turing teaches us that that is obviously true. So then the next question is, how painful is this going to be?
Right.
So I started writing, to test my hypothesis in that dialect, in this free dialect of JavaScript, to get a sense of how painful it's going to be to live life without this. And to my surprise, it got easier, and my programs were smaller and better. So,
oh, really?
Yeah, using this kind of kept me in the object-oriented paradigm, except JavaScript doesn't really do objects that well. So, it's kind of that.
Yeah, it's weird prototypal.
Yeah.
Yeah.
Whereas when I went totally functional, everything just made so much more sense. It was so much clearer and better. So now I'm a big advocate for functional programming in JavaScript.
Mm-hmm. Do you have any pointers really quickly on how to do functional programming in JavaScript? How to get off these crutches?
Yeah, so check out my latest book, How JavaScript Works. So in that book, there's lots and lots of programming, and there is no this anywhere. Well, I take that back. There's one chapter about this, but it's mostly an advisory chapter about why you don't want to use it.
Makes sense. So you were involved in JavaScript pretty early on. How did you decide what went in? I guess I should back up, because there was a meme, and I'm sure you're aware of this, that went around the internet where it was like the complete JavaScript manual, and it was like this thick book, and then JavaScript, the good parts, and it was this thin little book. How did you decide what went into the good parts?
It was avoiding the things that were mistakes. Some of the bad parts are unavoidable. I called those awful parts. So, like the plus sign does addition concatenation, and that's the only way you can add, but it's a dangerous operator because you might accidentally concatenate and you don't get any warning, and suddenly your numbers are many orders of magnitude bigger than they're supposed to be.
Right.
That's a huge problem. And it didn't need to be in the language. The language could have had a separate concatenation operator, which would have made so much more sense. But it didn't, and so we're kind of stuck with that. So that's a hazard in the language. So the best you can do is warn about it, but there's no way that you can remove that feature.
Right.
For other features, it was just observing how things worked, like automatic semicolon insertion, which a lot of people love, is a terrible thing because it can mask errors, make it harder to write correct programs. It would have been better had JavaScript been a semicolon-free language, but it wasn't. Do you know how automatic semicolon insertion works?
I've read up on it, but I don't remember all of the rules.
Yeah, so one of the rules is as the parser is going along, if it gets an error, sees an error, and if there is a line break in the vicinity of the error, then it will replace the line break with a semicolon, back up, and try again.
Uh-huh.
That should freak you out, right?
Yeah.
How could that possibly work? And it turns out it works most of the time.
Yep.
But sometimes it fails. And you don't want to rely on a feature that only works most of the time. Because how often is it acceptable to occasionally have an error in your program? Never, right? You're supposed to have 0 errors in your program.
Well, the other thing is if you occasionally have the error crop up, then it becomes really hard to figure out where and why it's happening.
Yeah, it's confusing and weird. And so I recommend always put the semicolon in. So every time you go, and it's not that hard.
Right.
And there are hipsters out there who hate me because they really want to be writing without the semicolons. And I've seen them do crazy, stupid stuff, like in cases where a missing semicolon would cause one of these errors, they'll put an exclamation point as a prefix operator, which is nuts, right? But they do that in order to, so they're replacing semicolons with exclamation points just because they don't want to be using semicolons. So the reason all of this happened was the original goal for JavaScript was to be a language for beginners. People who were not professional programmers could use the browser similar to the way the previous generation had used HyperCard, where you could just write these little scripts attached to event handlers that could add lots of interesting functionality.
Right.
And unfortunately, JavaScript's syntax was inspired by Java's, which was inspired by C++'s, which was inspired by C's, which was inspired by B's. And all of these languages have very complex rules for which statements require semicolons and which don't. And beginners can't make sense out of that.
Right.
So to simplify, it has automatic semicolon insertion, but it doesn't always work. It sometimes puts them in places where it shouldn't and sometimes doesn't put it in places where it should. So my advice is, if you're professional, you don't need that, right? If you're a professional, you understand how the grammar works. You understand where the semicolons go. You can write the syntax correctly. Or if you can't, there are tools like JSlint, which will tell you exactly where they go. And if you're programming in that way, then that is a class of errors that you can't possibly make. And you'll never have to waste time correcting them.
Yep, that makes sense. So as you built out this idea around how JavaScript works and the good parts and the bad parts, or the parts you want to avoid if you can, I remember diving into things like JSlint. Do you want to just explain the origin of JSlint for us?
Yeah, so my first year writing JavaScript was really painful because I imagined it was a different language than it was. And so, I remember once it frustrated me so much, I punched a cubicle and almost broke my hand. It was just, I hate this language and what it's doing to me. It's just awful. Then when I figured out what the language was about, I thought, okay, there's a good language in here, but there's also this bad language which keeps screwing me up. So I'll write a tool to help defend me against those problems. So I wrote this tool just for my own use, and I wrote it in JavaScript, and it was inspired by an earlier tool called lint, which was developed for C. And the first versions of C were also insecure in that way, and that there were lots of gaps in the language and problems and misfeatures and so on. And the lint tool would advise you on when those things were happening. And so if your program was approved by the lint tool, then you were confident that there was a large class of common errors that you were not making, which was a good thing.
Right.
So I made a JSlint tool to do the same thing. And over the years, JSlint made me smarter about what the good parts were, because I started with everybody else. I love the syntax, it's fashion, it's fun. I had an emotional connection to all of that stuff. I had a blind spot as to what it was doing to me. And as I'm designing JSlint, I'm trying to figure out what are the rules that I can put on this stuff so that a static analysis will find the most bugs. And there are some features of the language which make static analysis difficult or impossible. And I looked at those features and asked, well, do you really need those? And it turns out No, you don't. You really don't.
Right.
So get rid of them. So if you're using one of those features, even if it's not an error in this instance, we'll say, this is problematic. This is not good code because it's difficult to reason about.
Mm-hmm.
We cannot statically analyze this code and figure out if it's good or not. So that would reject things like the with statement. For a while, people were being very inventive with the with statement and finding all these very clever things.
Uh-huh.
So for a number of problems, it was very convenient, but there was never a case where it wasn't confusing. And confusion is what bugs are, right?
Yep.
A bug is when we think the program is doing one thing and it's doing something else.
Right.
We're confused about what the program is doing. So any feature of the language which is likely to increase confusion is something we want to avoid using.
Right. Yeah, that makes sense. I mean, and to your point, it's, you know what you want it to do, and it may actually be doing that thing, but yeah, you don't have the guarantees that you would have if you did it the other way.
Yeah, so I very reluctantly started compiling this list of bad parts, which go, well, yeah, that's problematic. It either makes reasoning more difficult or it's obviously a class of errors, like the ++ operator.
Yep.
People love the ++ operator. ++ was added to the C language for incrementing pointers.
Yep.
We've since determined that pointer arithmetic is harmful, so we don't do that anymore. Our modern C++ was the last language to do pointer arithmetic. And that's a language that is so fundamentally bad, it was named after the ++ operator. But we still have ++. All it does now is add one to a variable.
A lot of languages have a ++.
Yeah, and it's this thing we form, this deep romantic attachment to ++. It's not a rational thing. And one specific problem with ++ is it's got a pre-increment form and a post-increment form, which look virtually the same. And it's really easy to get them flipped, right? Mm-hmm. And that causes an off-by-one error. And off-by-one errors are really hard to find and expensive.
Oh, yeah.
And this one is particularly hard to debug because it's only off by one for an instant, right? Because eventually they all go to the next number, but when it goes to the next number, you might capture it in a bad intermediate state. And so I looked at that and I look at my code and I got ++s all over the place, but eventually I had to realize this is bad. The other problem with ++ is it encourages a style of programming called one-liners. Right, where you try to take as much stuff as you can and try to compress it all into one line.
I've never done that.
You've never done that?
I'm totally...
Yeah. It's hard not to do that. And we know, we have lots of empirical evidence that is a really bad way to write programs. Operating system exposures, like buffer overruns, are almost always using ++ in an inappropriate way.
Right.
Some uses of ++ found their way into the C standard library, so things like stir copy. Turns out that's a really evil function, and we're trying to remove that now from the C paradigm. But it's hard because people love it because it's got a ++ in it. So, and that affected me too. And anytime I got a C++ going on, this thing takes hold of me, and I know it's stupid, and I can't stop it. It's this compulsion. So I finally one day decided I'm done. I'm not going to use C++ ever again. And then I could relax. And life is good. Food tastes better. And it's just, this is so good. All this time I thought I had to be using ++, and it turns out it's completely unnecessary. I can write +=1, and that's just fine. And there's no ambiguity in +=1 as to when the addition occurs. Right?
Yes, true.
It's so much easier to understand. And it's a little bit more typing instead of going, you have to go, But, it's really not hard. So at first I had a flag in JSlint, so you could turn off the ++ warnings.
Right.
And eventually I decided, no, I'm being irresponsible. By having that flag, I'm allowing people to continue not learning how to program correctly. So eventually I took that flag out. And so JSlint always says, you shouldn't be using ++. That's a really bad idea. And a lot of people get really upset about that. They start to cry, wow, you can't take ++ away from me. They're like the NRA, right? They're coming after our ++s. And it's not that at all. I'm not coming after anybody. I'm not criticizing anybody. I'm just trying to discovered this on the mountaintop. It wasn't a very high mountaintop, but I was on a mountain and I saw that we can do better without plus plus. Turns out plus plus was a mistake. And if we avoid using that mistake, we can more easily write better programs. And that's what we should be focused on.
Yeah, I think it's interesting too, because a lot of the things you're talking about are things that, it's not something that's going to cause me a problem right now, right? At least generally it won't. But somewhere down the road, it could eventually cause me a problem. And they're hard to find.
Yeah, it could cause a problem for you, or it could cause a problem for someone on your team.
Right.
Yeah, or it could cause a problem for future you. Future you might have forgotten why you did that. And my God, what have I done? So we can defend ourselves from that. Write stuff of high quality for the team and for ourselves, so that, because we imagine we spend most of our time coding, right? I'm typing my program, and that's not the case. We spend most of our time debugging or maintaining.
Mm-hmm.
And so if you want to optimize, it's not optimizing the keystrokes when we're writing the program. It's optimizing the lifecycle costs.
Right. So one thing that, if I remember correctly, you've been fairly involved in the evolution of JavaScript. So, ECMAScript 3 to 4 to 5. I think when we talked to Brendan Eich a few years ago, he mentioned that, you had been in some of those discussions. Mm-hmm. And I'm curious, as you've looked at these things and said, these things are problematic, I'm sure you brought these up as they, updated the ECMAScript standard.
So I joined TC39, which is the ECMA committee that is responsible for JavaScript.
Right.
When they were working on ES4. And I thought ES4 was a mess. Basically, it was an attempt to radically transform the language into a different language. And they had 3 type systems in it. It was just wildly complicated. And I recommended that they not do that they do something similar or simpler, which, upset everybody. You can't come in now. We've been working on this for years, and you can't tell us that we can't do this stuff. And they were all angry. And so I started reaching out to other people who, at that time, there was nobody except me on TC39 who wrote in the language.
Oh, really?
Yeah, they were all compiler jocks. They were all guys who were implementing the language, but none of them were actually using the language. And so there was... It's
interesting, just to interrupt you there for a second, talking to people who work in, again, like Ruby or Python or, Java or people like that. Yeah. You talk to the language designers and they're working on VM code or, so Python and Ruby, they're C programmers. They're not Ruby programmers or Python programmers. Java language designers, they're JVM bytecode developers, not Java developers. And so, there's parallels in a lot of the communities that people are involved in that are going to be listening to this.
Yeah, so they're doing things because they would be useful in some other context.
Right.
Or they might just be fun to implement. I read about this feature in this other language, and I thought, boy, I'd like to get one of those in this one.
Yeah, or somebody's saying this is a problem in the current version, but they're not looking at how it's actually going to be used, or they have some vague idea of how it's actually going to be used. But since they don't use the language, they don't have a full set of context for it.
Yeah, so I went out of ECMA and tried to bring more people into the process. So I brought other parts of Google in. I brought IBM in. I brought the Dojo guys in back when there were Dojo guys. I think there's still Dojo guys somewhere. So
yeah, we've had them on the show.
Yeah, great stuff. So trying to increase the number of eyes looking at this thing, and hopefully we could get consensus on doing a better thing. Couldn't do that. So what we did was we forked the project. So ES4 continued ignoring all of our warnings and complaints. And we started another project that we called 3.1, which was something that followed 3 but was going to be much less ambitious. And the 2 projects were proceeding in parallel. And the meetings at that time were really, really painful because we'd all get into one room and we'd glare at each other. And there's all this tension and unhappiness. And then we'd break into separate rooms where we'd work on our separate proposals. And we'd come back and glare some more and then go home. And this went on for seems like for decades. So it's just a really painful process. In the end, we finished the ES3 proposal, and the ES4 proposal never got finished. That proposal was developed over a period of 10 years and effectively slipped a year per year over all of that time. They were never able to converge on a finished specification. So in the end, we decided not to publish ES4, and because there was a lot of the argument escaped from the committee and went out into the wild, so there are now people on the web who are arguing about whether ES4 should happen or not, and about these terrible people who are trying to stop progress and things like that. So we were concerned that if we published the 3.1 spec as 4, people would get really confused.
Right.
So we decided that we're not going to publish 4, and we published 3.1 as the 5th edition. And so the 5th edition went out, and it added some good stuff. We got the strict mode and some other improvements. And then we started the 6th edition, and the 6th edition was going to take a year or 2.5 years, we estimated. And it went much longer than that. And added a whole bunch of stuff that hadn't been considered important when we began. Most of it, I think we were wrong. A lot of bad stuff got into ES6. And my effectiveness on the committee vanished at that point. I had spent all of my karma points stopping ES4 and making ES5 happen.
Right.
At that point, a language committee can be a lot like Congress. If you're familiar with the pork barrel idea, my state needs a thing and your state needs a thing, and they're both pretty stupid and neither are interesting for the country and probably neither should happen. But if you'll vote for my stupid thing, I'll vote for your stupid thing, and we spend the money.
Yep.
Language features are like that. I got this. I got this thing I want in the language. You don't care about it, but you got another thing that I don't care about. So we'll both agree to vote in favor of each other's features, and we all go on. And so it's really easy for committees to bloat a standard.
Yeah.
And it is impossible for a committee to minimize a standard. Once something gets in, particularly JavaScript, because it happens on the web, the programmer or the operator does not get to choose which version of JavaScript is going to be run. It's the user who decides. And usually for the user, it is not an informed decision. Right.
So, it's whatever version of the browser I have and whatever version of the VM.
In most cases, it's whatever was on the machine when they bought it.
Yeah.
That's not quite as true now because we finally got the auto update thing working everywhere. Yeah. But back then, it was absolutely true.
Yeah, but even then, so I have Chrome or Firefox or whatever that auto updates itself. It still doesn't have all of the ES6 or ES, 2017, 18, 19 version features in there. And so it's still not 100% consistent or reliable.
Yeah, so the most important feature that we added to ES6, well, maybe the most important was modules. Modules are really important. And unfortunately, the module system we got is way too complicated, as often happens. But there is a subset of it which is very simple, which is good. It works. And that should replace the terrible require thing that we got on Node. We should be using import and export in JavaScript, the simplest possible form. No stars, none of that. Just export one thing and import as many things as you need.
And I'm generally seeing more of that as we move along.
Then the second most important feature in ES6 was proper tail calls. And that's needed for functional programming. With proper tail calls, it's also called tail call optimization. It means that if the last thing a function does is return the result of calling a function, then the function call return sequence gets replaced by a goto. So it's a goto with parameters. And that turns out to be a brilliant thing. It can make certain classes of programs much faster, and it makes loops unnecessary. It enables a style programming called continuation passing style, and it allows us to do things in a functional mode, in a pure functional mode, that you cannot do if you're using loops. So that's a really important thing. That's how we can advance everybody to writing much better programs in a functional style. Unfortunately, Microsoft couldn't figure out how to implement it on the CLR. So they've been saying, that, they dug in and said, we're not going to do it. And they convinced most of the other browser makers not to do it either. Apple, maybe just because they hate Microsoft so much, decided to do it anyway. So Safari, you can get proper tail calls. One of the problems with the way we named the feature, tail call optimization sounds like it should be optional. We could do the optimization or not. Proper tail calls means this is the right way to do it. It's not an optimization. It's fundamentally more important than that. So the purists won, and we went with that name. The problem with that name is it doesn't sound like anything that you ever heard of, and you don't want to do it. Whereas optimizations, the coders love optimizations. If they can do something that's an optimization, even if it makes their program bigger and slower, they want to do it because they love optimizing, right?
And you can do it in a one-liner, harkening back to what we have earlier.
Yeah, exactly. They're smart optimizations and they're very dumb optimizations. This one is a really smart one.
Right.
And I think if on the feature list, if it had said optimization, then the coders would go, yeah, where's the optimization? We want the optimization. But instead it said proper. And propriety means nothing to those guys, right? So there's no demand for it. So as a result, ES6 implementation is still not finished, which is really frustrating. We should have had that by now.
Right. This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give you full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code devchat at Sentry.io to get 2 months free on Sentry's small plan. That's code devchat at Sentry.io. It's interesting, too, because a lot of times we just assume that the browsers are going to implement all of the standard. And so
they should. The language provides no facility for subsetting the language.
Right.
This is the thing. If you want to say you're compliant to ES6, you have to implement all of this stuff. There's an appendix of stuff which is optional, which you don't have to implement, but you probably want to do anyway.
Right.
But tail calls are not there. They are in the thick part of the specification. So we need to tell the browser makers, finish this thing. So fortunately, Microsoft has left the browser world, right? They are now in Chromium.
Yes.
So their objection to this should disappear if they're running V8 instead of their stuff. And I think V8 implemented it. It's just hidden behind a flag. If we convince these guys now, turn it on. Let us do tail recursion. Let us write functional programs, and the world gets a little bit better.
Oh, yeah, absolutely. So then it sounds like you have mixed feelings about the progression of JavaScript with ES6 and then ES7 or ES20, whatever, 17. So I can't remember ES6 corresponds to what year. I can't remember what year. Anyway, so do you feel like we're making progress, or do you feel like we're more regressing with the new language features, or how is that working out?
It's clutter. We're adding stuff that we really don't need. We're adding new syntax. We're adding new stuff. Some of it's new paradigm stuff, but often it's the wrong stuff.
Right. Like
promises were a really good idea. Promises were invented in a company that I founded many years ago. I had a company called Electric Communities, and there we're developing a new language called E, which was intended for doing secure distributed programming. And we invented promises as a way of helping to do that, managing protocols and so on. Promises then migrated to Python and then to JavaScript. And as it migrated, the really good parts of promises were lost. And so we're left with this little thing which is meant to manage asynchronicity, but it was not designed or intended to do that. That was sort of, it was so powerful it could do that too, but it doesn't do it very well. So W3C said, we're going to put that into the W3 specs. And TC39 said, you can't do that. That belongs to us. They said, well, we're going to do it. And so you can't do it, so we're going to do it. So we just put it into ES6 really fast without really thinking it through. And there are things that are fundamentally wrong in it that will never get fixed, and we're just stuck with that.
Yeah, that was one of the features that I never understood why it couldn't just remain in a library, honestly.
Exactly. And people are trying to put RX into the language. And RX was one of the good ideas to come out of Microsoft. It's great, but it works really well in a library. There's no reason to burden the language with that.
Well, and if I'm not going to use it, then why should I load it and then tell it to compile it out or whatever if I'm not going to use it? I don't know.
Yeah, it adds clutter to the language, and we've got this nice module system in it now. So if you really need it, you can say import RX, and you're done.
Yep. And then import the operators that I want, and we're good to go.
Yeah, so my feeling is that we should only be adding things to the language which are fundamental. And we cannot go forward with the language unless these things are built in.
Right.
And proper tail calls is one of those.
Yeah, I see, because that's at the level of this is how functions interact with each other. And so, it's at a fundamental language level. It's not something that I can pull in a library and say, oh, this is going to, this will update the way that the functions, call into each other as we do functional programming.
Yeah, you can't fix that. So we need the language implementation to get finished for ES6.
So is this something then that we can, I guess, since we're adding all this clutter to the language and things like that, I mean, if I'm just not using those, is the language still getting better then for me? Or
well, the problem is you may not be using them, but other people are.
Right.
And so you're not going to have to probably import crap that's using all of this stuff, and now you're stuck with that. Like, you may have a much smarter way of handling asynchronicity than promises.
Right.
But you're importing all these libraries that say, no, you got to use promises. So now either you have to write an interface layer or,
right,
crap. So given the community thing, the bad features are recommending bad practice. People will do, the standard says it's there and they wouldn't put crap in the standard, right? So it must be good to use. So, the standard itself becomes an attractive nuisance.
Yeah. So I guess my question is, for things like if they put tail call optimization in and, they're putting in the continuation passing style and all of these other things that you're talking about that you like with the new language features, on balance, is it a good trade-off then, the direction we're heading, versus some of the garbage that gets thrown in there that, might be better off not in the language? On balance, is the trade-off good or bad or a hard call to make?
We really should have a complexity budget. TC39 should have some kind of complexity score that they can add to each feature. Each feature can have complexity between 1 and 100. And the total of all of those features should be less than 20, say.
Right.
You should spend or invest your complexity points very cautiously. Only places where you think there's going to be a big payoff. But there isn't anything like that. There is no complexity budget. They can add as much complexity as they want. In fact, there's often an inverse effect, that there is a fallacy which says, if we can add more complexity to the language, that means we won't need as much complexity in our programs. Turns out that's not true at all.
I can see how you can make that leap, but it's not always going to be true.
Yeah, exactly. So, for example, there's a proposed feature called big integers. Big integers are a good idea, but it turns out you don't need them in the language. They're easy to implement as a library. And in fact, in my book, one of the early chapters shows how to implement that library and shows some of the things that you can do with such a library. So there's no necessity argument for big integers. There is maybe a convenience argument because a built-in feature might be a little easier to use than an imported feature. And then there may be a syntax argument that it looks prettier to do it this way than another, and we love a fashion-based argument. From my perspective, fashion-based arguments should be considered priority 0.
Right.
So we don't need big integers. I can give you a library that will do them, and for most applications, it's going to be fast enough. Unless you're doing something like Bitcoin mining in a browser, I don't think we want to be encouraging that anyway. So we shouldn't be adding affordances. Most applications don't need big integers. Again, there's no reason why they should have to tolerate new syntax for a feature that most applications will never use.
Yeah, fair enough. So I kind of want to change tactics a little bit. Are you going to write more JavaScript, the good parts, and for the new features, and say, yeah, these are new, bad, or ugly, and these are new, good, or whatever?
Yeah. So how JavaScript works reconsiders the good parts.
Okay.
And there are things that I recommended as good parts that I now consider to be bad parts. So the good part set continues to get smaller and smaller and smaller. My energy going forward is focusing on the next language.
Okay.
I don't think JavaScript should be the last programming language, because if it is, that'd be really sad.
Right.
And the legacy, right? You don't want your kids to be writing in JavaScript.
I think you hurt some people's feelings saying that. I know a lot of people that really love JavaScript,
and I do too. JavaScript has been really good to me.
Yeah.
But this should not be the end of programming languages. There should be a language that comes after this, which is better, that is informed by our collective experience with JavaScript.
Well, and that makes sense, because you look at, for example, the way that we build buildings now, right? And you realize, we built this one, using these techniques with, steel and concrete and this, that, and the other. And then you invent some better way to build the building. You can't go in a lot of cases, and retroactively, undo and redo in that building. The next building is going to stand up better to whatever we're going to throw at it. And so in some ways, we want to keep progressing with JavaScript to make it better. But we also, if there's a better way to do it in the future, then we have something else that will stand up better to earthquakes or wind or, whatever else is going to come at it. And so, there should be a next language. There should always be a next language.
Exactly. Otherwise, we would still be writing in Fortran.
Yeah, we'd still be building with wooden pegs and...
Yeah, so we'd be programming
roughly milled trees.
So next year we'd be looking forward to Fortran 2020, going,
woo!
Yeah. What are they going to do next? It's like evolution, right? We start with little bits of mutation, and then there's something that's more radical, right? C comes out. C was a major departure. It's still, there's a lot of Fortran left in C, but it was thinking very differently about a lot of things.
Right.
It could do structured programming. It could do pointer manipulation. It could do a lot of things. It could do dynamic memory allocation. Fortran couldn't do any of that stuff. So C is a step forward. And then we recognize, turns out pointers are a bad thing, because there's this huge class of errors that you can make with explicit pointer management. So we get Java. Java is a big step forward from C. Mm-hmm. But Java is really heavyweight and complex.
Oh, yeah.
And JavaScript is really light and nice and facile in a way that Java is not. And that's a lot of why JavaScript won. Java was supposed to be the language of the browser. JavaScript was supposed to be the language of the server. JavaScript is replacing both of those, right?
Right.
JavaScript got a lot of stuff right. And in my view, what it got right was lambdas or functions that operate as lambdas with dynamic objects. Mm-hmm. Putting those two things together was brilliant. It was genius. And Brendan Eich deserves so much credit for having done that, because that was just spectacularly smart. A lot of the other stuff he got wrong was borrowed from other languages. Most of what's wrong with JavaScript came from Java. Mm-hmm. And so the next language should follow on that trajectory that Brendan established. He kind of pointed, it goes in this direction. And the next thing we need to consider is getting better at distributed programming. The model of programming going back to Fortran was you've got one machine, one address space, you've got a program that runs in that address space, and that's the whole thing. And that's not true anymore, right? We now have programs that are running on lots of machines. We've got multiple tiers, multiple servers, networks, places. It's all going out there. But we're still writing in the Fortran paradigm, trying to distribute our programs over all of this stuff. So I think
seeing this movement in the Ruby community, a lot of people are moving to Elixir, which takes advantage of a lot of this kind of thing with the distributed and processes and all the things you're talking about here.
Yeah, that stuff comes right out of Erlang, which is brilliant. Erlang said, no, we got to have all these little lightweight processes with inter-process communication. Erlang didn't get it quite right in that for efficiency, they allow for shared memory. And we now know shared anything is a bad thing. So we want all of these things to be independent. So the next language, I think, should take the things that Erlang got right and things that JavaScript got right, and maybe a couple other languages which are also rightful, and push in that direction.
Right. So you're talking about writing a language for distributed systems. I mean, what other features would this next language have?
We need to think a lot harder about security.
Yes.
It used to be security all happens within that one address space, but when we start splaying stuff out over the internet, we have learned the hard way over many years now that doesn't work. So security needs to be factored into the design of the language. It's not something that should be pasted on after, because we know that doesn't work. So we want to have a system for managing and assigning capabilities which is guaranteed not to leak and immune to confusion and other sorts of attacks, so that we can have more confidence in the distributed systems that we're developing. Mm-hmm. And JavaScript will never be that language.
Right.
It has too much old stuff in it and too many oldish ideas being added still that it can never offer those levels of security. We could cut JavaScript way down and turn it into a secure language.
Right.
In fact, there's a project called Dr. Sess, which is doing that. It's a distributed, reliable, secure ECMAScript. But that is not ECMAScript. It looks very similar, but it's a different language. It's a subsetted language. So that's a much better approach.
That's Dr. Sess?
Dr. Sess. Mark Miller is one of the major architects of that. Brilliant stuff.
Yeah, I'm just trying to find it on the internet. Dr. Sess?
SES.
SES. Oh, here we go. Cool. So it sounds like you said you're working on this language now. Are you just working on a standard? Is it implemented somewhere?
No, I'm working on an implementation. So I've been working on this language since I was in college. And as I've gone through my career, as I've learned more and experienced more, as I've hopefully gotten smarter as a result of all of that, my idea about what this language should be has changed radically many times over the years. So it was originally called Crocktran, back when Fortran was a thing. So this was going to be a better Fortran. For a while, it was called Candy when I was at Atari. And then Ply was another version of it at Atari. And then later it became Elemento. And in my book, I describe a language called Neo, which is sort of a transitional language for going from JavaScript to the next language. And currently the name of the next language is Misty. And Misty sort of identifies the vaporware nature of this project because it's been going on almost my entire life. And I'm hoping to finish it soon. But given my track record with this language, there's not much certainty of that.
Oh, maybe we can get you some help, have some people come in and contribute to it.
That would be swell.
Nice. So I'm curious, because you have so much background in JavaScript, I'm wondering, are you looking at some kind of implementation in the browser that maybe compiles to WebAssembly, or are you looking at more sort of a VM that runs on the server like Node, or?
No, I'm Misty goes directly to machine language.
Okay.
And I'm also designing a CPU architecture which would be better than, say, the current ARM architecture for this particular language. So a lot of the things that we're trying to build into hardware and system software for security, this adds that to the language processor in a very different way. So I'm working on two implementations or two designs. One is something that can run on existing machines, and the other is something that I hope I can convince some maker of heavy silicon to take on.
Right. Yeah, I've seen people do this kind of thing with other systems. So, for example, I'm trying to remember the name of it, but I went to an Erlang conference, and yeah, they had they had hardware that was basically built around and optimized for Erlang, it's compiled Erlang. And so, it ran basically on the silicon, and a lot of the functionality was, hardware instead of, VM functionality. So,
yeah. So for a long time, it has been really hard to make specialized CPUs because Intel was writing Moore's Law, and no matter what you did, in a couple of years, they would just roll over you.
Right.
I think they're at about the peak now. They cannot make the Intel architecture go any faster than it can currently. So what they can do is they can give us multiples.
Yes, they give you more cores.
Yeah, but without better tools for distributed programming, that really doesn't do us much good.
Right.
Right. You've got, my laptop's got 8 cores in it, and most of them are idle all the time. So that's not really helping. So we're at the point now where architectural cleverness may actually be effective against Intel's model.
Interesting.
There are so many inefficiencies in the Intel model. And Intel has known that from the beginning and has been trying to get away from that model. They did the 8080, which was sort of the first implementation of it. And that wasn't even their design. That came to them from another company called DataPoint, a company in San Antonio.
Right.
They were making intelligent terminals, and they wanted a chip that they could put into the intelligent terminal that would simplify the design and reduce the cost. And then it got sold into hobby machines and started the CPU thing. Then the Z80 came out of that, and the 8085, and Intel decided we need to stop making this little thing and do something serious. So they had a project called the 432, which was going to be a micro mainframe, this really powerful machine with security and garbage collection and distributed programming and fail-safe operation, all this stuff built into hardware. And that project failed. So suddenly they had competitors who were bringing stuff to market, and their thing wasn't going anywhere. So they shipped the 8086 really fast. And that was basically a Z80 machine kind of upgraded a little bit to be 16 bits. And they recognized that was a mistake, so they built the 960 and the 860, and none of those were adopted by the market. And then they tried to do the Iridium thing with HP, and that didn't get adopted either. Mm-hmm. Meanwhile, AMD tried to do the 29000, which was brilliant, but that didn't sell. So AMD does the AMD 64, which is just some kludges on top of the 86. Major hit. And so today everything's running from that. So there are so many attempts to try to get away from the Intel architecture, and they all failed. Mostly, well, who knows why, but familiarity seems to be more important than quality. So at least in CPU architecture.
Right. Well, that'll be interesting just to see how far we can get. If we do get to the point, though, where we can run Misty on custom hardware, do you see then a fragmenting of some kind to some of this other architecture? I mean, to Misty or to something else maybe that is optimized for other systems or languages and more distributed stuff? Or is that kind of a pipe dream?
So I imagine there are going to be a lot of devices that would like to have a Misty chip in them.
Right.
And then the Misty chips will all communicate to each other securely over the Misty protocol. The Misty protocol is mostly just JSON.
Right.
So legacy machines should also be able to talk to those devices as well.
Right.
So one of the nice things about having JSON as the connecting fabric between all of our distributed programs is that it doesn't matter what language the programs are written in.
Right.
I could be writing in Erlang and you could be writing in Java, and our programs can communicate.
Right.
So that's great. So whereas in the Java model, they tried to do Java serialization, which means every program in the network has to be running Java.
Right.
And they all have to be at the same level, and all the class files have to be of the same type. And that turned out to be...
Yeah, that gets messy.
Yeah.
Yeah, because your JVM languages, they don't play nicely unless they're all talking to the same JVM version.
Yeah, and that turns out to be surprisingly hard to do.
Yep. Interesting. So one last thing that I want to highlight, because we're kind of getting toward the end of our time, and I want to be respectful of your time. I did run across the Front End Masters course, and that was part of what kind of prompted this. So do you want to just talk for a minute about what you talked about there and what people would learn from that course?
Yeah, so that's an introduction to functional programming. So I take you through a series of very simple functions, and over the course of that, I'm hoping to take you through a paradigm shift. So we've had a number of paradigm shifts in the history of programming, and when one of these happens, it's something you can experience, but you can't explain. So high-level languages, you could tell someone who is a machine language programmer, if you go to a higher-level language, you can be so much faster and it's so much easier, but they go, no, it can't work. Giving up too much control, I don't want to do that.
Right.
We had a similar thing with structured programming. We had a similar thing with object-oriented programming. We have a similar thing now with functional programming. Functional programming is the thing that we need to do or be going toward.
Right.
But if I tell you, well, you just need to be writing functions that return functions, you go, yeah, I understand that. I know what those words mean, but it doesn't make any sense. It isn't until you've actually experienced that you can then embrace that paradigm. And so that's what that workshop is about, is I help you to cross that or to achieve that paradigm shift by taking you through these exercises. And over the course of a day, you should be able to do it.
Yeah, that makes sense. So besides Misty, are there other things that you're working on these days that people can follow?
I'm working on another book, but it's not about programming, and it's not anything that anyone can follow yet.
Okay. It's not about programming. It's about
a man named Charles Bliss.
All the smartest men are named Charles. Let's say that.
Yeah. So he was an Austrian-Australian who did some amazing work in languages, and his story is a very interesting story. So I'm hoping someday to write that book.
Oh, I gotcha. So it's a biography?
It's a biography.
Very cool. I love seeing sort of the other side of people, because we get on, we talk about code, right? And then it's like, okay, so I know who Doug Crockford, the JavaScript developer, JavaScript, advocate or, language designer is. But then I don't get to see the rest of Doug Crockford, the guy who's into these historical ideas and, who he's paying attention to and what really gets his interest when he's not advocating for tail call optimization and things like that. So, yeah,
it turns out history is really important.
Yeah.
The thing I like most about the way physics is taught in university is that the first course is usually a history course. And we'll go to Archimedes, we'll go to Galileo, and, do all the guys, Newton and so on, and sort of look at the progression of how physics was invented or discovered and how it grows and how we make progress in the field, which is wonderful. And we don't do anything like that in computer science. That there's no history class. There's nothing about how we got here. So lacking that, being in a vacuum, you might imagine, well, I guess the smartest guys in the world got together and they decide, well, this is just how it's going to work. And it was not like that at all. There were some very smart people, many of whom did brilliant stuff, which we have lost sight of. There's some particular track through the possibility space of computer science that we have taken, but there were so many other paths which are brilliant and wonderful and may still work for us, which are completely ignored.
Right.
And so, I would really like to see a bigger emphasis on history in the way we teach programming.
Yeah, I can definitely get behind that. Back when we were starting up new shows, one of the shows that got started was Views on Vue. And one of the things that was really fun about that is that I got to know a bunch of really terrific people in the Vue community. And furthermore, one thing that happened that really hadn't happened on any of the other shows, we actually got a member of the core team to come on as a regular panelist on the show. We have Chris Fritz on there. The other thing is you may recognize some of the other voices. Ben Hong, who's on the official Vue News podcast, is also a panelist on the show. He's worked for Politico and now works for GitLab. We also have a bunch of other terrific panelists that come on and talk to you about what's going on in the Vue community. And because they're so closely tied to Vue and they talk to people about Vue all the time, they're very up to date and very knowledgeable about what's going on in the Vue community. So if you're looking for a way to learn Vue.js, or if you're looking for a way to stay current with Vue.js and kind of have the water cooler conversations you wish you could have about it in places where maybe they're not using it, then definitely check it out. You can find it at viewsonvue.com. All right. Well, the last segment of the show is picks. And this is just shout outs about things that we're into, things that we're enjoying, stuff like that. So I'll go ahead and go first. That way you can kind of get an idea of some of the things that we're looking at. The first pick that I have is a book that I've been reading by Pat Flynn. Now, if you're not familiar with Pat Flynn, he has a podcast called Smart Passive Income. I've been aware of Pat since before he kind of got big in the podcasting space and the entrepreneurship space, because I listened to another podcast that's not on anymore. And those guys helped him get his business start. The book is called Superfans, and it just talks about interacting with people who want to be part of your community, who are fans of you and what you do, and how to bring more people up to the level of being super fans instead of just casual followers and things like that. And for me, what it really boiled down to is there are two things. One is that I really love interacting with people who are fans of the show and enjoy the shows. And I don't know what that was.
Oh, that's my phone. Try to ignore that.
It's all good. But yeah, so essentially, I love interacting with folks, and this is a way for me to get to know people on a deeper level. As I bring people up to the point where they are super fans, then I have more enriching and rewarding experiences with them. And so that's kind of what I'm looking at there. And then the other pick that I have, I bought a course from Neil Patel. It's an SEO course, and that's something that I've been working on for devchat.tv. And so he's been walking, he has a different thing that you do every day for like 3 or 4 weeks. And they're all things that can help increase the SEO and web traffic on your website. And the reason is because I put out all this content and I'm trying to help people out as far as learning and growing and being better programmers. And I want more people to be able to find it. And so this is one area where I've been pushing a little bit to see if I can increase things there. And so I've been going through it. It's called Agency Unlocked. He has an SEO agency, but this is kind of a DIY walkthrough. And the level I'm at as far as editing and setting up websites and stuff, I kind of like doing the DIY because then I can see how all the pieces go together. It's kind of the same reason why I like working on my car, is because, I know what's in it and then how it all goes together. And I know that it got put together the right way. So yeah, so I'm really enjoying that as well. So I'll put links to those in the show notes. Doug, do you have some things you want to shout out about?
Yeah, a couple. First is The Art of Computer Programming by Donald Knuth. Everybody who is a professional programmer should have read these books. Knuth teaches or taught at Stanford University and planned a series of 5 volumes about programming. And the books kind of grew and grew and grew over the years. So he is partway through volume 4 now. And hopefully he's going to live long enough to finish the whole thing because it's brilliant. The first 3 books have been out for a long time. In fact, they were available when I was in college. Then he took some time off to invent digital typesetting in order to make his books better as the old metal type was going obsolete. Then he rewrote the first 3 volumes to reflect newer technology. A few years ago, he published, in that time, the material in volume 4 has grown so much that it's actually going to be several volumes. So volume 4A came out a few years ago and was great. I'm hoping volume 4B comes out this year. And there'll probably be maybe a couple more in volume 4. And then finally we'll get to volume 5, which is about programming languages, which should be great. So I highly recommend Knuth. He's a brilliant writer. Everything you want to know about algorithms is in those books. It's great stuff. Then the other one is there's this series that was on HBO called Game of Thrones, which was great. I think it's the best program in the history of television. It's a dark epic fantasy, which is huge in its scope, a vast number of characters, very unconventional in its storytelling, in that things you think are likely to be heroes, you're going to follow to the end, die off really quickly. And it sort of set the level of expectations very, very high, so high that some people were unable to appreciate the final couple of seasons because they were expecting something different than what the show wanted to do, which just because it was so amazingly good. So I picked that.
Nice. Yeah. I resisted watching it for a long time, and I think I'm currently in the middle of season 5. So yeah, we'll see where we end up. I tend to watch it when I'm traveling. So
yeah, that's how it was for me. I tried watching the first episode and I got about a third through it and going, I don't know what this is. It's so cold, and why do I care about this stuff? Then I was on an airplane and saw a couple of episodes from season 2 and had no idea who these people were or what they were doing, but it was fascinating. So I went back and watched it all, and wow, this is great. This is really, really good stuff.
Yeah, it's extremely well put together. So, and from what I understand, it stays reasonably close to the books. I haven't read the books, so.
Well, it does for a while, but it gets ahead of the books.
Yes.
So George R. R. Martin, his rate of output has decreased significantly. And so they were able to follow the books fairly closely. They necessarily had to simplify because,
yes,
you can never do the book if the book is big. And his books are really big. But they got to the point where the books weren't done yet. And so they had to invent stuff. So they extrapolated from what they had already done and interpolated with what he suggested might happen in later books and created this stuff. And there's some people who said the show took a big drop in quality when that happened. I didn't see it. I thought it was brilliant all the way to the end.
Yeah, see, like I haven't read the book, so I don't know at what point where the transition happens. So another book series that I've enjoyed that has been made into TV shows is The Expanse. And those also stick reasonably close to the books.
I've only seen one episode of that. I need to catch up on the rest of it.
Yeah, it's interesting too with a lot of these. Yeah, the first episode or two of the first season, The Expanse kind of gets you into it pretty fast. But yeah, Game of Thrones, I think it took me an episode or two to really kind of go, okay, I figured I'd give it 3 or 4 episodes. And then if I just didn't get what people were excited about, then I wouldn't watch any more of it. But yeah, once it kind of gets rolling, it really takes off. And it's a terrific series. All right. One last thing, Doug. If people want to get in touch with you or see what you're working on, follow your work, where are the best places to do that?
Crockford.com.
Okay.
So I have a website named after me, and that's where you can find my stuff. You can find my email address there.
Yeah, your email, your social, blog, all that stuff.
Yeah.
Okay, good. Good deal. All right. Well, then we'll put that in the show notes as well. Well, thanks for coming and talking to us, Doug. I'm sure people are going to reach out and say, you didn't ask him this. So I may see if you want to come back one of these days, and we'll have conversations about other stuff.
All right.
All right, folks, we're going to wrap this one up. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.